Alrighty. Moving on from operant conditioning to classical conditioning. So this is um, associated even more with dogs here and Pavlov. And yeah, let's get into it. So this is a bit different, obviously, from operant condition, in that it involves an association between two stimuli. And so this graph chart here is the or figure is the most simplified way to present classical conditioning. Basically, the idea is that we will have an unconditioned stimulus that is just automatically leads to an unconditioned response. And then classical conditioning occurs when these two stimuli are paired, so the unconditioned stimulus and the conditioned stimulus, so that then the conditioned stimulus also leads to the response. So there are kind of five parts here. I'll just use the classic Pavlov example. With dogs. And so the unconditioned stimulus in the case of Pavlov and the dogs would be the food. The unconditioned response would then be salivation. The dogs just salivate when they smell that food. Then there's also a neutral stimulus. And so this, in the example, Pavlov's research is a bell. So this is something that the bell is neutral because it has typically no effect on the dog, right? But when the neutral stimulus is paired with that unconditioned stimulus, the food, it becomes a conditioned stimulus. And so the bell then leads to the final aspect, which is the conditioned response, which is that same initial response and salivation, but now that salivation occurs at the sound of the bell, not just when that food is presented. So it occurs with that conditioned stimulus, and this process is called classical conditioning. Another example here, we have Pavlov and Homer Simpson. And so the unconditioned stimulus based on the show, Homer Simpson, right, really likes donuts. And so when the unconditioned stimulus is just automatically paired, or not paired, just leads to the unconditioned response of Homer Simpson salivating. But then when these two things are paired together, the bell, which was previously neutral stimulus, then that becomes a conditioned stimulus and leads to a conditioned response where now Homer Simpson is salivating due to that bell. And so, again, this is different from operant conditioning, right? Operant conditioning was are we behave in a certain way based on a stimulus, and then that behavior is either reinforced or punished, and then that influences the bond between the stimulus and the behavior, right? With classical conditioning, this involves associating two stimuli, which produces a response based on the expectation that these are going to be paired together again in the future, and that there will be co-occurrence. The expectation then is that when Homer hears the bell, there should be a donut close by. And so this classical conditioning process is learning, right? So when a conditioned stimulus is paired with an unconditioned stimulus, this should increase the strength of that response to the conditioned stimulus, right? And so, yeah, that in a nutshell is classical conditioning. However, we can also have what's called extinction, which is where that behavior begins to dwindle and go away. And so this typically happens in the absence of that unconditioned stimulus. And so if there's just the bell, or, in the video that we watched in the end of the last lecture, where there's the dog that is behaving based on the clicker, right? So that clicker is the conditioned stimulus. And so the expectation is that it's going to be paired with the unconditioned stimulus. When that doesn't happen, we see this extinction where the dog figures out, like, okay, you're still using this clicker at me, but it's not being paired with the food anymore. It hasn't been in a long time. So why am I going to do this behavior? I don't want to shake your hand if I'm not going to get the treat, if I'm just going to get this clicker that was paired, but now I'm kind of starting to forget that it's paired because they haven't actually been, the conditioned stimulus and unconditioned stimulus haven't been associated in a while. There can also be spontaneous remission or kind of a regeneration of the behavior, and that can happen, as in the name, spontaneously, kind of out of nowhere. Most commonly, that'll occur if the conditioned stimulus and unconditioned stimulus are paired together again. But yeah, this typically this learned association lasts for as long as the conditioned stimulus is occasionally again paired with the unconditioned stimulus. When that stops, that's when extinction occurs, and this learned behavior will start to decrease and eventually become extinct. An additional idea that comes along with classical conditioning is contingency learning. That, I mean, in a nutshell, kind of is what classical conditioning is. But the idea that I want to point out on this slide is that there can be additional pairings along with what was initially tried to be paired. So watch this video, and I think that it'll help explain what I'm getting at here. And watch this video about little Albert and probably feel a little bad for little Albert watching this video. But basically what happens is that there is a generalization of the response to a conditioned stimulus. And so little Albert is kind of trained to be fearful of a white rat. And that's due to it being paired with a loud noise again and again. Little Albert wasn't originally afraid of that white rat. And then you also see that not only does Albert become afraid of that conditioned stimulus, little Albert also becomes afraid of other animals, little furry things. So Albert would likely be afraid. He was walking around town and saw a dog, would likely be fearful of that, or went to the mall and saw Santa Claus, would probably also honestly be afraid of that. So yeah, give that video a watch, and hopefully that'll kind of clear up what I'm saying here. But yeah, just to emphasize, that's the idea of generalization gradients. And so the closer a new or different stimulus is to the original presented conditioned stimulus, the stronger the response will be. So for an example, if someone is trained to be fearful of a water bottle for whatever reason, and then is presented with either a mug or a plate, that individual is probably going to be more fearful of the mug than the plate, because it's more similar to the water bottle. This chart gets at that idea as well, just with the color blue. So if someone is, again, for some reason, made to be fearful of this shade of blue, the closer the shade is, the more that fear response should be present. This idea can be used for good in what is called graduated exposure therapy. And so this is actually a relatively common therapy for getting over various fears. So for an example, if this child is fearful of heights, we will slowly get the child accustomed or exposed to heights, right? So not going to just right off the bat have the child go to the top of a building like this, going to have the child maybe stand on a chair first, and once that becomes more comfortable, then move on to a step ladder, something a little higher, before having the child climb an actual ladder, again getting a little higher, and then eventually, before you know it, the child might be playing tennis or ping pong or whatever that is on the top of an airplane. Yeah, so I'm certainly no expert in the realm of clinical therapy or anything like that, but this is the general idea of graduated exposure therapy, classical conditioning, or this contingency learning is the origin of that. An interesting application is that new technology can help with this, and so VR exposure specifically. So the fear of flying, for an example, is called aviophobia. But the problem is, how would you do therapy for this, right? Because it's hard to gradually move to that. It's like either you're on the plane or you're not. And so this is where things like VR exposure can really come into play and help. And so it allows you to get some extent of exposure to, for an example, again, the fear of or being on a flight in this virtual setting. And so you can go through stages like being just at the airport to getting onto the plane, sitting down, getting some sort of a feeling of taking off. And we see that this is successful, especially with aviophobia, in reducing negative affect based on this fear. Now, we've covered two main research-based theories for learning, but there are certainly some limitations. I know that real prominent figures in this field like Watson and Skinner believed that learning explains everything, right? That genes, evolution, how the mind is set up, the whole biopsych, that doesn't really mean anything. It's all about just learning and reinforcing behaviors or punishing them, strengthening or decreasing those bonds between associations. And so, that's obviously the complete opposite of what we talked about in the beginning of this class, right? Where we were going over the importance of evolutionary theories, sociobiological theory, things like that. And during that previous section, it was like, well, this doesn't seem to explain everything. And learning also doesn't seem to explain everything, providing some evidence that, well, there's probably some nature and nurture at play here. And so most studies that support this theory use species-specific behavior, and that's important, right? And so then it becomes learning's actually just a redirection of what we are instinctually capable of doing. And so, for an example, like us as humans, right, you can be rewarded for flapping your arms really fast. That behavior can be reinforced so that you just keep doing it, but it's not going to help us fly, right? Because we're limited in that way. Kind of an interesting study, I think, an example of this is there's a study where raccoons were trained through conditioning to take a quarter, put it in the machine to get a bag of chips, to get some food. So they would walk down the hallway with this quarter, put it in, get the food. Interestingly, though, when raccoons were given two quarters together, they wouldn't end up with two bags of chips. They would actually end up rubbing the two coins together. And so that is evidence of then bringing out more of an instinctual behavior as opposed to the learned behavior, because they instinctually will rub things together in the form of 'cause that's what they do for washing food typically. And so, yeah, that um, brings out what doesn't need a behavior that doesn't need to be learned. Finally, a couple other examples of limitations are some contingencies, like what we see with classical conditioning. Some are learned more easily than others. I'll have an example of that on the next slide. And finally, we'll talk about this in the next section. Learning can occur without direct reinforcement. Last slide here for this section. Just want to point out an example of how some things are learned more quickly than others. We see this in taste aversion, also called the Garcia effects. And so we see that taste and illness are more easily associated than some other associations, even with large time intervals. So maybe we'll have our own personal examples of that. Like if you got maybe food poisoning or felt sick after sushi or something, it's likely that you went a very long period of time, if not, forever, without wanting to eat sushi again. Or if the first time you drank, you went a little overboard with one type of alcohol and now, you can't drink vodka anymore. That would be another example of this. And so it's just evidence of I'm talking about here. So in this study, rats were exposed to either a little bit of radiation or a shock. And, obviously that radiation is going to make them feel sick. And then they also had either just general water that was paired with a noise or light, or instead they just had sugar water. And as you can see, the rats would then intake much less water with taste or with that sugar when feeling sick. So that's example of taste aversion, right? Versus when it was just when the punishment was a shock, they stayed away, drank less of that water with noise that was paired with either noise or light. And so the idea, or the takeaway from this better, is that learned associations like taste aversion depend on the punishment modality. So it's not, you don't see equivalent associations, right, for each punishment. Otherwise, this would all be the same. All right, so that's it for classical conditioning. In the final section on learning, we will go over vicarious learning.